All in today's online session. Hope you are fine and having the help. We start today's session with the verse of Holy Quran. Until now, anyone of you, if you have any kind of question, query, or difficulty, then feel free to discuss. I will answer the kind of question and resolve your queries if you have in your mind. So, in previous session, we've all discussed about the HVDC transmission system and how the three link used to transport electricity via HVDC system and the impact of HVDC system by the conductor of DC positive negative. We check and observe these systems. So hopefully all the things being clear in your mind, and we further moving towards the concept of HV, high voltage direct current system, advantages and disadvantages. So coming back to the concept of advantages and disadvantages of high voltage DC power system, the advantages of HVDC transmission systems are only number one is the only one or two conductors are required for HVDC transmission, whereas three conductors are required for an AC transmission. Hence, the cost involved is comparatively less. It can carry more power at the same operating voltage. There is a considerable economy in insulation for the same operating voltage. The insulation between the tower and the conductor and the clearance above the earth required is small when compared to the AC lines. Number four, due to the absence of charging current and stability limits, there is no limitation of distance for power transfer. Dielectric power loss in cables is less in DC or power system than in AC. Hence, the current carrying capacity of cables can be increased considerably. Number six, there is no skin effect, so smaller size conductors can be used. By the synchronous link provided between two DC systems, the problem of voltage control, system stability, and frequency control is simplified. Number eight, corona loss and ratio interference problems are less in DC. In long HVDC transmission lines, the receiving end voltages does not rise above the sending end voltage, which is the Franti effect concept. So the Franti effect concept is no more in HVDC transmission line of system, as this concept too much impact and emphasize the HVDC transmission system, HVAC transmission system, sorry. Number 10, detection and clearance of fault is faster. The short circuit current required is low than compared to AC systems. By having a DC link in parallel with an AC link, the stability limit of the existing AC system can be increased, so the existing AC lines can be used for high capacity transmission. So in number 13, no reactive compensation is required, as in concept in HVAC systems to normalize the concept, normalize the effect by reactive compensation. There is a possibility of using the ground as return path. Furthermore, the disadvantage of HVDC transmission system. So we need to discuss the disadvantage as well in HVDC system. Uh, the concept and the lecture topic is on HVDC and it have some disadvantage as well. Reactive power cannot be transmitted through a DC line. The terminal equipment for conversion from AC to DC and back to AC is expensive. This concept of converting from AC to DC and then DC to again AC from sending and receiving and respectively, the concept is expensive and a vital aspect, key aspect in HVDC system. But we need to use the kind of this concept. The protection scheme of a DC system is expensive because conventionally the price aspect concept is typical in HVDC, but HVAC concept variety parameters device are simple, but in DC it's a complex. In number three, after a short break, we further continue the session. After number three, ripples and harmonics are generated when AC is converted into DC, both on the AC and the DC side, necessitating installation of filters for their elimination. Number five, voltage cannot be step up in HVDC system because there is no concept of transformer in HVDC. So we need to use a concept, the conversion from DC to AC and then step up. And before DC, we need to step up in AC and then after step up, we need to convert by the rectifier in DC and then further use for particular purpose of HVDC systems. So this is the main vital disadvantages for HVDC, which are quite less, but HVAC have more disadvantage as compared to HVDC, sorry. So this is the concept and lecture about HVDC. We further moving towards the next aspect related to the HVDC power system. Further, we discuss the concept of HVDC system, current technologies and future trend of HVDC power system. So further major and upcoming trends that would be highlight in our HVDC power system that plays a remarkable role in the future terminologies and technologies as well. The current technologies and future trend of HVDC systems are nowadays for distance less than 500 kilometer. Most economical option is HVAC. HVDC is considered the best option for power transmission in near future. Construction for new HVDC power lines is difficult due to social or political reasons. So conversion of AC lines into DC lines is highly remarkable. And due to these conversions, harmonics losses, power electronic space losses should be counted, but this loss is less as the loss of electricity, wastage of electricity in losses in HVAC systems. One of the economic modes to make this convert conversation possible, con- conversion possible is modifications in tower structure. Due to high investment cost, this concept is most feasible for distribution lines instead of transmission lines. For conversion of AC lines into DC lines, VSC technology is most versatile for converting converter stations as compared to LCC, the line commutated converter. So in this technology and terminologies, the commutation, force commutation, line commutation, disk commutation, continuous commutation, the concept are used further. Due to startup complexities, HVDC supergrid can be made possible after this conversion. Further, embedded HVDC has more benefits as compared to classical HVDC. So embedded means embedded technology. Embedded HVDC shows superior applications in offshore wind farms. So offshores are not connected with grid are called offshore wind farms. power sharing between weak AC system and high load centers. So these are the offshore wind farms which feed supply to weak AC system directly, provide supply, lossless supply provided to the HV system, which are the weak AC systems, and high load centers. In feed large urban areas and DC segmented grid. Embedded HVDC uses applications of semiconductor devices. Due to low cost of semiconductor devices in future, HVDC power transmission system will become more feasible. HVDC link used with a synchronous compensator can provide proper mechanical inertia. So it is a cheaper solution and powerful tool for performance improvement. Further, offshore wind farms are considered as huge power sources and can be integrated with other resources of energy to meet increased energy requirement. An example of such a system is HVDC interconnected between Norway and Great Britain. So these are the two ways of connected of HVDC transmission of power system with each other. As far as transmission of bulk power over long distance is concerned, HVAC has its limits, which supports the concept of standalone HVDC transmission system. Some limitations of HVAC transmission system like connecting asynchronous systems can be addressed with HVDC interconnections, but transferring bulk power using HVAC lines over long distance remains a problem due to capacitance inductance of overhead lines, which limit the transmission capacity. Standalone HVDC transmission systems, however, have no such limitations. In case of HVDC, the reactive components do not limit the transmission capacity of line. Also, there is no skin effect in DC lines due to which the conductor cross section can be fully exploited, which is not overcome in HVAC because this concept is related with the frequency oriented aspect, but in DC transmission system, DC power system, there is no concept of frequency, so further no concept of skin effect. So the internal cross section of cable of conductor fully exploit in HVDC system, especially for HVDC transmission line power conductor cables. Digitally controlled system can have more control over power flow. The towers needed for HVDC transmission lines are also smaller in size as compared to HVAC, hence less costly. There are different schemes of HVDC transmission capable of transferring bulk power from several hundred to thousand megawatt in HVDC transmission power system, like in bipolar HVDC system already discussed in our previous session, or long distance which can be adapted according to requirements of power system as well. Moreover, to meet the growing energy needs of the world, there is a wondering shift to generate power from renewables. So it's a future of technology as well. With the increased renewable energy generation, the grids need to be supplied and must be capable of handling the irregular power delivered from the renewable. HVDC is only ideal option to meet these requirements. It would not be wrong to say that HVDC got its revival due to increased production of energy by renewables. Why revival? Because in starting, the Edison, Thomas de Silva Edison produced electricity in DC, but Tesla produced electricity in HVAC or AC. So there is a clash or war between AC current and DC current in the starting ages of centuries. And before AC, there is a remarkable evolution of electricity in DC. DC produce, DC generate, DC transmit, DC utilize in many of the loads. So this is the uniqueness of DC system. Now world evolved and moving towards again to HVDC, because we produce electricity in DC by solar system, by windmills, by solar power plants, wind power plants, and tidal other kinds of system which produce electricity in DC, transmission in DC, and again, and somehow it will also be utilizing in DC as well. And some of the load in like LEDs are also glow and provide electricity. LEDs and DC pump also utilization in DC. DC is the future in coming days, in couple of years as well. So this is the future of an evolution of DC technology that we moving and achieving now these days continuously due to the increasing efficiency. Long distance transmission from offshore source to onshore grids using HVDC is the only cost effective option. It allows HVAC to relate to renewable sources with improved power quality, stability, and reliability. With the use of HVDC, operators can immediately change the direction of power flow, making it possible to transmit renewable energy between countries. So this is the concept of HVDC and current terminologies and technology evolution, revolution in HVDC systems, and it is the future of technology as well, you can say. So moving towards these concepts, these are the challenging aspect for us as well. Having said that, when we are concerned with the conversion of DC to AC, sliding model control, that is SMC, is a control technology used to control active and reactive power and power factor, which also tells the quality of power, that how much reactive content is available in lagging aspect for HVDC link. In case of VSC, variable switching control, in HVDC, transients better performance is obtained in HVDC system with LCC rectifier and MMC converter, which is rectified in the this rectifier is location on the transmitting side, and MMC converter is in receiving side of the HVDC transmission line. Current regulator designed at rectifier end at minimize current oscillations at inverted terminal. Power quality problem in grid can be mitigated by using PHEV as regulators. Hybrid approach, which combines different combinations of HSC, variable switching control, and LCC, inverter rectifier technology. Immunity of LCC and HVDC linked to communication failure can be enhanced out there. So this would be the last slide of today's lecture. The understanding of HVDC insulation system and their reliability is hot area of research now these days and needs more exploration in upcoming of months and years as well. Characterization and aging of insulating materials used in HVDC transformers as a function of dielectric. So I'm talking about the HVDC transformers in my previous session. So the function of dielectric, stress, temperature, and moisture needs a lot of investigation. For example, development of new solid insulating material like Vepri board with better conductivity and matches with oil. The monitoring of oil conductivity throughout the life of HVDC converters must be adopted in order to ensure its reliability. But remember one thing, the possibility and availability of DC transformer is too much and very much costly, because only Siemens developed the HVDC transformer, and it is like a booster, not like a transformer. So it is not directly a transformer which is directly step up, but the terminologies are the a boost converter and like a buck converter, which is step up or step down like a AC transformer. So these are the possibility applications of DC transformer is limited, and only Siemens contribute in this challenge. Research and analysis on insulation system behavior under combined DC and AC stress is also needed. The main reason for TINs is that HVDC transformers are tested separately with AC and DC voltages. However, during operation, they are subject to both type of voltages at the same time. So this is the all about today's session. Up till now, anyone of you, if have any kind of question, query, or difficulty, please feel free to discuss. I will answer the kind of question and resolve your queries if you have. So hopefully all things being clear in your mind and you have no kind of question. So we need to end today's session. Allah Hafiz.